For 9.5 on your own, you're going to be doing certain parts of this page here. So you're not doing the graphing part. So we are just focusing on writing our inequalities right now. So let me grab a pen and let's get started. So when cooking chicken, the recommended internal temperature of the chicken is shown. So we are trying to get it to 165. A lower internal temperature will undercook the chicken. Write an inequality to describe the temperatures T at which chicken will be undercooked. So we are trying to show anything that will undercook the chicken. So I'm comparing it to T. And now I need to start thinking about this. So if I cook the chicken to 165 degrees, is that undercooked? No. So it's not going to equal 165. So I know it's not, so I'm comparing it to 165, and I know it's not going to have that line here. It's not going to have that equals mark. So now I've got to decide, is my sign going to go this way or this way? So these are undercooked, right? These temperatures are undercooked. So anything less than 165 is undercooked. So that means anything less than 165, so temperatures less than 165 are undercooked, right? And if it's 165, it's cooked, so it's not equal to it. So let's just double check ourselves. And so let's come up with a solution set to help ourselves know what T could be. So if I cook the chicken to 140, is that undercooked? Yes, that would be true. If I cook the chicken to 159, is that undercooked? Yes, that is true. If I cook the chicken to 164 degrees, is that undercooked still? Yes, right? And I would not put 165 in here because once it reaches 165, it is cooked. So T, anything that is undercooked, is less than 165. So then I could also flip that around and do 165 is greater than T. So anything bigger than 165 will be cooked. Anything less than that is undercooked. So for number 5, it says the speed of sound is approximately 761 miles per hour. For an object to produce a sonic boom, it must travel faster than the speed of sound. So we've got to go faster than this. Write an inequality to describe the speeds S at which a moving object will produce a sonic boom. So I have S and I have 761. So we are trying to show what will make a sonic boom. I know sonic booms have to go faster than 761. So sonic booms travel faster, so greater than 761. So now I need to decide, is it including 761? So this says the speed of sound is 761. To produce it, it just says it has to be faster. So it doesn't say it can equal this. It doesn't say at least that. It says it has to be faster than that. So it is not going to include 761. It does not have that equal sign. So let's think about some things and just double check ourselves. So if I put here, right, if it goes 762 miles, that would create a sonic boom. If it goes 761.2 miles, that's greater, and that would produce a sonic boom. Right? 761 is just sound. That's not a boom. It's just sound. I could make it go 800 miles, and that would be greater and create a sonic boom. So we're taking our two things. We have S and we have 761, and we just have to decide, is it going to be, which way is our inequality facing? Put in some answers for your variable and see, does that make sense? So, right, I want it bigger and faster. This would be bigger, so I need the bigger side to S, but it's not including that. For 6, we are finding the area of a rectangle, and the length has to be multiplied by the width. So it's telling us we have to do L times W. A farmer needs to build a fence to enclose a chicken pen with an area greater than or equal to 50 square feet. The length of the fence must be 10 feet. So his total area has to be at least 50, right? It has to be 50 or greater. It can be 50, but it has to be at least that. The length of the fence must be 10, so we are finding W here. Write an inequality to describe the widths that will yield a fenced-in area of at least 50 square feet. Ooh, this is kind of like 2 problems in 1. Oh, hi, please ignore this. I started doing the wrong problem. I didn't pay attention. Okay, so we are not comparing W to 50. The area is compared to 50. We first have to find what W would be to equal 50. So we know L is 10, so we've known 10, and we were going to times that by W, and we need that to equal 50. So the opposite of timesing by 10 is to divide by 10, and I'm going to show that balance on both sides. So W equals, right, 50 divided by 10, 10, 20, 30, 40, 50 equals 5. So W can be 5. But that's the smallest that it can be. So down here we have W, and we want to compare that to 5 because it says it can be bigger than that. So if I do 10 times 5, that is 50, that equals 50. But the area of the fence can also be bigger than that. So we are taking W, and we are going to compare that to 5. Now, I need to start thinking, if I make W 4, 4 times 10 is only going to be 40, and that is not going to be true, right? It has to be at least 50. So I know I can't go smaller. So I can do exactly 5, so I know, right, at least, those words at least, told me I can have an equal sign here, and we have one up here. It can be bigger than that. It can be at least 50. So what happens if I make the width 6? Does this make the statement true? 6 times 10 is 60. That's the area of 60 is greater than or equal to 50. That would be true. So W can be greater than 5. It can't be less than it. W needs to be bigger than 5. It can be equal to 5. It cannot be smaller than 5. So let's come up with a few things. So can it be 5? Yes, because 5 times 10 is 50, and it can equal 50. Could the width be 6? Yes, we proved that. Could the width be 10? 10 times 10 is 100. That is greater than 50. So there's just a few solutions. So we need W to be greater or equal to 5. So every time, get your variable, get the number you're comparing it to, and then decide whatever you put over here, should this be bigger or smaller than the number you're comparing it to. So just try some solutions. That's what I always do. So sometimes I can't just be like, oh, and my symbol goes that way. I just start thinking, okay, what if I put in this? What happens? Is that true? What if I try this? Did that make it true? To see, should this be bigger or smaller? Because some of them can kind of get tricky with their wording. Okay, so we're going to skip to 7 and do both parts of 7. So the temperature in Minneapolis was -9 degrees Fahrenheit. The next day, the temperature in Minneapolis was warmer than 9 degrees Fahrenheit. So I am just going to draw myself a little thermometer here. So it was -9. Sounds cold. One day, and then the next day it was warmer, right? So that's going to go up. That doesn't mean it was above 0 necessarily. It just means it was warmer. It was just above that. So write an inequality, which is true, only for temperatures T that are warmer than 9 degrees F. So we are comparing T and -9. And we want these temperatures, the T, to be warmer. So I'm going to start asking myself, right, I want T to be bigger. So T is greater than -9. Can it equal 9? No, because it has to be warmer. And if it's -9 and -9, that's the same. That's not warmer. So T could equal things like, let's just double check ourselves. If I put -8, -8 is warmer than -9. If I put -10, that would not work. So right, it can't be 10, that would be colder. What if I put 0 degrees? 0 is greater than -10, that would work. Let's try -1. -1, right, is above -9. So those are just some possible solutions of warmer temperatures. So now B asks us, could the temperature have been -12 in Minneapolis the next day? So -12 would be down here. So would -12 make this inequality true, and explain why or why not? So I know these can kind of get confusing. I really have to think every time, what way does my symbol go? I just have to start thinking, right? I'm comparing it to T. T is warmer. I need bigger numbers over here. Or if it wants T is colder, I need smaller. And just come up with some solutions and see if they make sense.